So now in this video we have a weird circuit, but it's more of a demonstration circuit than anything. This is a PNP bipolar junction transistor. We have a resistor on the emitter side right there, and that makes it a current source technically. So we have our load on the collector side over there, which is going to be an LED, which lights up when you pass more current through it. So there you can see we got more current, less current right there. The way that we get more current to flow. So remember, this is the emitter. It's going to the positive supply of the power supply. Now I put another symbol next to it, the ground symbol right there, 0 volts, because you could use that instead. But if you do, then the more negative voltage will be a negative voltage right there. Hopefully that makes sense. So usually you have ground and then a more positive voltage as well as a negative voltage if you have negative voltage, but you don't always have to. Any case, sometimes PNP is on the low side of a circuit, and an NPN bipolar junction transistor is on the high side right there. So you can do a push-pull. There's a bunch of options. So that's what that symbol means right there. We're going to just stick with the positive supply and ground for this video. So, in any case, we have the emitter going to the positive supply, the resistor there. So, when it starts passing current along here, a lot more current's going to flow in this direction right there, going through the LED. Now, the way we start getting current, and this is why we cannot just short this to ground if I put the trim pot all the way down to the negative supply, we got the 10K resistor there because we need to not take away all the current going that way, or the LED will not light up if we get all the way to ground right there. We always need some resistance, but the voltage should transfer over. Now, the way that the voltage transfers over, we have 5 volts at the emitter, and then we need a voltage difference of about 0.6 volts basically at the base, or lower right there. And if we go all the way up to the positive supply, which we have now, we will have 5 volts at the base, 5 volts at the emitter. No current is going to flow because we got 5 volts up there. There's no voltage difference right now. If I lower the voltage of the trim pot, so once I get about 0.6 volts lower, about 4.4 volts, that's when the LED starts lighting up a little bit. And if I keep turning it down, you can see the LED gets brighter. At some point, it's not going to get brighter anymore. And remember, the LED has a forward voltage of about 2 volts, so that leaves us a maximum about 3 volts that we can use to set the current. So probably like somewhere over here we hit our current limit. And if I go down a little bit, it's going to go down a little bit. So if I get 2.2 volts across this resistor right there, in order to do so, I got to be about 0.6 volts lower over there. So I'm guessing about 2.8 volts. I'm not going to be able to fine tune it, but we're going to get the multimeter coming up. So I'll try to do it there. But yeah, 2.2 volts across the 220 ohm resistor is 10 milliamps of current. That's going to go through the LED. If we don't have the LED, if we just went to ground, again, this is going to give us about 10 milliamps of current. It's a current source. The load doesn't set the current at all. That resistor does, although the load does take voltage if there is a load, if we don't just have a jumper going to ground, and therefore we lose the maximum amount of voltage we can work with. We can only get, somewhere about 3 volts across that 220 ohm resistor. But in any case, PNP bipolar junction transistor. The lower the voltage, the more current you're going to get. The higher the signal voltage right there, the less current you're going to get. So now I pretty much got the multimeter ready. Just have to set it for V for voltage. It's auto ranging. If it has numbers, set it to a number higher than you're going to measure. Red probe stays here for everything but high current, so we don't have to worry about that. But yeah, we got basically 5 volts right now at the trim pot. We're measuring the base. I have the alligator clips clipped to the probes right there, and then the clips are crimped to jumpers that I can plug into the breadboard on both sides right there. Red one over here. So we're looking at the base voltage in relationship to ground. So it's going to be a little bit confusing, but you can see as the base voltage lower, the LED gets brighter. And we got to be about, I'll dim the lamp so you can see it's a little bit easier. When the LED starts glowing a little bit, there you can see, it's about 0.6 volts, 0.7 volts approximately. Could be anywhere in that range, less than the 5 volts right there. So let's try to get about 10 milliamps of current, 220 ohm resistor there. So we want to go about 2.2 volts lower than 5 to start with. So that'll give us 2.8 volts. And then, so yeah, somewhere about 2.8. And then there's a 0.6 volt drop between the emitter and base. So we got to go about 0.6 volts less. And I actually did this a little earlier. It's going to be about 0.7 volts less. But in any case, we will go down about 0.6, so down to 2.2, which is kind of interesting. So 2.2 volts in relationship to ground right there should give us about 2.2 volts across that 220 ohm resistor. We're not going to drag this out. So we're going to go up to the emitter with the red probe. That's not going to give us the voltage across the resistor. That's the voltage in relationship to ground. So about 2.9 volts it looks like right there. So again, this doesn't work out perfectly. We can look at the voltage across the emitter resistor going this way. Positive supply up there. Pretty sure I got that plugged in right spot. So yeah, about 2.1 volts. So probably be a little less than 10 milliamps of current, but close enough. So now we finished measuring the voltage. We're going to start from scratch. I already turned the meter off, but one thing you can see, there we are. We're close to 10 milliamps of current on the power supply. So that's a really good sign. But we're going to actually measure the current coming through the collector. So to begin with, we don't have anything wired up. You got to be careful when you're going to measure current. So I'm going to set the meter to measure current in milliamps right there. We're going to be in the milliamp range. If there's numbers, set it to a number higher than you're going to measure. Again, this is not high current. I don't have to move the red probe for this particular meter right there. So to begin with, our current is going to go to ground. We can do that now. We have to open up the circuit before we can take a measurement. So we're going to ground. I'm going to make sure I set this off where it cannot accidentally measure current from something else. I don't have to worry about damaging the meter because the power supply is limited to 20 milliamps of current. So, you know, that's in the milliamp range. It will not blow the fuse. But in any case, it's best to pretend like at any time a bad measurement could blow the fuse, just to get good practice for being careful how you wire stuff up. So yeah, there's the red probe, the jumper. So we're gonna have to get the current that's gonna go through the LED through the meter as well, right there. So yeah, there you can see, yeah, a little bit less than 10 milliamps of current right there, as you know, we mentally calculated. So hopefully that all made sense. If not, read about basic electronics for current sources and stuff. But yeah, there we go. So we don't have to go through the LED to get that current. I haven't taken this measurement yet. I just know it. It's probably not going to be spot on the same, but really close to about 9.6 milliamps of current, which is what we have now. It was just a little bit less than 9.6. So there you can see 9.7. It's a little bit higher. As semiconductors warm up, they tend to conduct a little bit better than when they're cool. So that's how you risk thermal runaway. We don't have to worry about thermal runaway here. It's going to settle at some point. It's barely going up right now. It's going to go up even slower at some point till it stops right there. But yeah, we're bypassing the LED. It's not going through the LED, just through the jumper. Now the LED, which drops a couple volts, much harder for current to flow through than a short circuit to ground from the collector. It's not a short circuit across the power supply. It's just a short from the collector to ground when I was over here. Now it's going through the LED. For some reason, the LED was kind of linked to the jumper. And there we go. Basically, the exact same current. That's a current source. So, I probably dragged this on too long, thinking of it now. So, first, I'm going to unplug this again. You want to be very careful. You don't accidentally measure a voltage when it's set to current, even though I have plenty of precautions that nothing bad would happen now, but you got to get used to that. Make sure you disconnect everything completely, and then it's the best time to change the meter settings right there. You could also turn it off while you're measuring current, but you know, probably better this way. If there's a power button, don't leave it on current either. Set it to a voltage. That's always the safest thing to measure, is voltage by accident. But this has an off setting, so we set it there. So that's really about it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.